Okay, here we go. Create an int array with a random size between 40 and 50 elements using math.random. So int array nums equals new int. And then in here, we're going to do, oh, not there, right here, int math.random times, I said between 40 and 50, so 50 minus 40 is 10, plus 1 is 11, and then plus 40. That's an array, and we don't know how big it's going to be. That we're going to use nums.length for everything. Fill the array with random values from 3 to 7 inclusive. So to do that, we need a for loop. Nums.length plus. I'm going to do curly brackets here. We're going to fill this thing with random values. Nums I equals int math.random times, and we're doing 7 to 3 inclusive. So 7 minus 3 is 4, plus 1 is 5, and plus, close parens, plus 3. So that'll, guess I had one too many thing there. Good. Print the array on one line with a space between each value. So we can do that in the same thing here. System.out.print nums I plus space. I mean, it just got created. It's fine. And then after the loop, we're going to print a blank line. So the rest of the program looks good. Okay. Calculate and print the average of all the integers. So to do that, we need a sum variable. I'm going to say int sum equals 0. And I'm going to add up everything as we go along. Sum plus equals nums I. And then to print the average, plus, we're going to say 1.0 times sum divided by nums.length. I think it's time for me to run and see what I got so far. Every time you run it, it's going to be different because it's between 40 and 50 numbers. And then the average, will be close to 4.75, but I doubt we'd get exactly the same thing. That's probably right about in the middle. Yeah, look at that one. A lot more exciting. Okay, so I think I can get rid of all those instructions. Report how many times two numbers in a row are ascending. So to do this, we have to make a new for loop. So let's see, we need a count variable. For int I equals 0, I less than nums.length minus 1. I have to do the minus 1 because we're going to be doing a plus 1 inside the for loop. If nums I is less than nums I plus 1, if the current number is less than the next number, then we have an ascending pair. We say count plus plus. And we can print this out. Number of ascending pairs plus count. And I'm not going to want to check this in great detail, but let's, because I forgot a semicolon, but let's, do a quick eyeball check. Make sure it's logically appropriate. 16 pairs. So here's like a 3 before a 6. That's 1. 3, 5, 3, 4, that's 3, 3, 6, that's 4, 5, 6, 7, 8, 9. Yeah, I mean, this seems reasonable. I probably missed a couple. Okay. Create a new array and make it contain the original array in reverse order. So I'm going to make a new array, int reversed. I'm going to just call it revnums equals new int, and it's nums.length. We're going to do a for loop. Int I equals nums.length minus 1, I greater than -1, I minus minus. I'm going to go backwards. And so I'm going to start at the end of nums. We're going to put rev nums. And for this one, we want nums.length minus I minus 1 equals nums I. So this takes the very end of nums and puts it at the very beginning of rev nums. And why the I and the minus 1? Well, let's say that nums had 10 items in it. The last item is item 9. So that's right here. I starts at 9. And then we would want to store item 9 of nums in item 0 of rev nums. So we're going to do 10 minus 9 minus 1 gives us a 0. And we'll just print it out and make sure. System.out. Oh, sorry. For this one, let's do an enhanced for loop. For int n rev nums system.out.print n plus space. Whoops. And again, this thing. Okay. So then we'll get this ended 7453, and this starts 7453. I'm just checking that. And this started 6475, and it ends 6475. So that worked. Create an array of frog objects using your age as the size. That's going to be a lot of frogs for me. Frog array. Pond equals new frog. So we're hard coding the size for this one. Initialize each element with a new frog. You have to do that with a regular for loop. Int I equals 0, I less than pond.length, or I could say less than 59. It's just usually better form to just use the length. We're going to create a new frog and store it in each spot. So pond I, remember they're null to start with, equals new frog. And I'm going to hop the frog right now while I'm here. Pond I dot hop. And inside the hop, we're going to do a random integer int random. I said from 0 to 10. That's 11 spots. And we don't have to say plus 0 because that doesn't do anything. I'm going to print them all. System.out.println. And so you could do it later. We can just do it right now while we're here. And I asked you to report the index of the frog that hopped the farthest. So to do that, we kind of need to know which frog hopped the farthest. So frog farthest, I'm making a new frog, equals, I'm going to say on 0. Well, we'll see if this works. Like that one. No, that won't work. So I'm going to say new frog. The new frog hasn't hopped anywhere, and so its location is 0. And if they all, by random chance, had only hopped 0, then this would be a true statement. No, this is bad. I have to just do this later. So we're doing all the printing. And don't do a print len because we don't want them all jammed together. So we just have to find the index value of the frog that hopped the farthest. So 1 second. So here's all these frogs. Sweet. And it's a little silly when there's so many, and so many have jumped the farthest. I'm going to just say the first element of the first index of the frog who jumped the farthest, because there'll be repeats. So what we'll do now is say frog farthest equals pond 0, and int farthest distance equals farthest location. So now we know, we're just saying, hey, let's just say the first frog jumped the farthest. So we're setting that to be true. And now we're going to go through the whole array. We'll just use this again. I just need a close curly bracket. So if pond I dot get location greater than farthest, this is farthest index, sorry, and I'm setting it to 0 because we already know the location. We can get it anytime we want from here, but we want to keep track of the index there. So if pond I get location greater than farthest get location, then we have a new farthest. So farthest equals pond I, and so I need curly brackets here, and farthest index equals I. So we're then keeping track of how. And I guess I'm seeing this now. You could do this whole thing without creating a frog. You could just do it all with farthest index. Just keep track of the index. And then we would use pond index, farthest index instead of farthest here. But what I've done here should be fine. We'll find out, won't we? And system.out.println first frog who jumped the farthest at index and farthest index. So like I said, I'll have fully 9% of my frogs will have jumped the farthest, but this is telling us that at index 2 was the first frog that jumped the farthest, and looks accurate. I'm going to just rewrite this that other way. So farthest index is 0. So if pond I get location greater than pond farthest index get location, then farthest index is I. And that's a little simpler. So we're just keeping track of the index of the farthest, and we're using that index right here. And it starts out as 0, and then anytime we find one that topped farther, we just update the index variable. And that's all we really needed. We didn't need the actual frog on hand. So this one is 15. So it's all the way down to 15 before we get to the farthest spot. You can see that visually.